French fries. So we take potatoes and we put them through the slicer, which makes what? Sliced potatoes. And then we take sliced potatoes and we put them through the deep fryer, and that makes yummy French fries. That's a composition of functions. It's a function within a function. So it just means you're doing two things to a number. You're putting it through some kind of function, which we call f. You're taking whatever comes out of that function, putting it through a second function we call g. That's called a composition of functions. The notation looks like this, or like this. And we say those are both the exact same way. We call it f of g of x. F of g of x. What do you notice about a dot in the second notation? Yeah, that's the open or the white dot. That's why we made the distinction last class. Such a small difference, but completely changes what you're doing to the function. Don't copy this down, but just follow me. We started talking about this yesterday. If I give you that notation, what does it mean? Substitute 3 into whatever this function happens to be. And if I gave you like a crazy negative number, what does that mean? Substitute -1. And then we looked at if I just put a different variable, what does that mean? Substitute m. So really what we're doing is this, which is no different. What we're doing is substituting g for x. So you're putting a function inside a function. That's called a composition of functions. Just like yesterday, we're going to do it graphically first, then we'll do it algebraically. I use a ruler for this one, so if you're visual and want to use a ruler, you might want to grab one. The trick with these is we start with the inside function first. So what I'm going to do for a second is just ignore that f. I'm just going to do g of 2. And what does g of 2 mean? It says go where x is 2, go up to the g function, and figure out what the y value is. Okay, go where x equals 2, go up to the g function, figure out what the y value is. Offer of 1. So putting the f there because I haven't touched it yet, the inside is equal to 1. That's called the inside function. Now I'm going to go to the outside function, which I go where x equals 1. I take the function, and I say what the y value is. Offer of 2. That's a composition of function. That's it. It's just a function within a function. Well, the order matters, so I can do it backwards. Again, we still start with the inside function, so I'm just looking at the f of 2. That says go to 2, go to the f function, figure out what the y value is. Offer of 0. So I'm still going to keep that g, and I'm just going to replace f of 2 for 0. What does g of 0 mean? Go to where x equals 0, find the g function. We talked about the radicals yesterday. What happens when it's not there? Yeah, undefined, NA does not exist. I can change the value, and that's okay. So f of g of 1, we start with the inside first. We do g of 1. Go ahead and write down the value of g of 1. Compare with someone sitting around you, a little high five if you both have g of 1. G of 1 says you go where x equal to 1. You look at the g function. You get the y value. What's g of 1? Then we're left with f of 0. Go ahead and write down f of 0. What do we do when there's no graph there? Yeah, so we can just extend this line. We know that lines go on forever, so just extend it up. F of 0, 4-ish. We're okay with 4? That's a composition of functions. That's all it is. It's a function within a function. So what we did is we took an x, we first applied it to the g function, then we applied it to the f function. That's the equivalent of taking the potatoes, putting them through the slicer, then putting them through the deep fryer. This would be x, this would be the inside function, this would be the outside function. Let's do it algebraically. So given f of x is negative x minus 5 and g of x is x squared plus 2, we're going to find f of g of x, g of f of x, g of f of negative 2, and f of x. F of x. That is one of my favorite functions ever. What do we do with this when there's no x value? Well, we've done these before. This means we're taking g and we're putting it into f. So if you're visual, sometimes it helps to draw arrows. We're taking all of g and we're going to put it wherever we see x in f. We're taking all of g and putting it wherever we see x in f. So this is going to equal the negative that's in front of that x. Then I'm going to put some brackets and put my x squared plus 2. And then I still have that minus 5 hanging around at the back. So all I did was I took x out, and I put g of x in its place. This would be called an implicit function, and you don't actually need to know that. What you need to know is what's an explicit function, and that was in the homework from last class. It'll say state an explicit function for whatever. What do you think explicit means? If this is implicit, what's explicit? It just means simplified. Okay? So implicit means unsimplified, explicit means simplified. So if we wanted to give an explicit function, we would just go ahead and get rid of those brackets. So this is going to give us negative x squared, negative 2, negative 5. And then collecting the like terms, negative x squared, negative 7. So you might want to jot down that vocabulary word. Explicit function means simplified. Explicit, simplified. What's the difference between f of g of x and g of f of x? Well, it's just what function we're putting into where. This we took g of x and put it into f. This we're going to take f and put it into g. So I'm going to take all of f and I'm going to replace them in g. So this becomes in brackets negative x negative 5 squared. And then I still have that plus 2 at the back of my g of x. Okay, so all I did was take x out of g of x, put f in its place. Again, that's called a composition of functions. Write an explicit function for letter B. What do I do with negative x negative 5 squared? Now what your brain might want to do is start to distribute this exponent. And people go at negative x squared, and then negative 5 squared is 25. Is that how we do a binomial squared? No, that's kitten killing up on the poster. We can't distribute an exponent when it's a binomial. What do we do then? We FOIL it. So sometimes it helps to write it out twice so your brain can see that you're multiplying the same binomial times itself. Again, you don't have to do that. Just some brains it's easier than trying to distribute the exponent. So we're going to have negative x times negative x. Negative x times negative x. Perfect. The outside is negative x times negative 5. The inside is negative 5 times negative x. The last terms is negative 5 times negative 5. And then I still had that 2 that was hanging around. And so simplifying the like terms, my explicit function would be x squared plus 10x plus 27. All those negatives, and there's no negatives down here. Math is awesome. Just repeating, this is called explicit because it's simplified. You don't need to know, but this would be called implicit when it's unsimplified. How are we doing so far? Thumbs up, thumbs up. Well, the only difference in C, instead of having an x, I'm going to stick a number in there. This is exactly what we did with the graph. What we're going to start with is just the inside function. What does that mean, f of negative 2? It means go to the f function and substitute in negative 2 for x. So f of negative 2 is going to equal negative 2 minus 5. Negative 2 minus 5, that's a lot of negatives. Offer of negative 3. So that means I'm going to take g of negative 3. G of negative 3 means go to the g function, replace negative 3 for x. G of negative 3 equals? Offer of 11. F of x. Say that 5 times fast. F of x. What does that mean? Take f and stick it in itself. So we're taking all of f and putting him into himself. It's kind of a weird, you can't see what I just did there. Taking f and putting him into himself. That's kind of a really weird thing. So I'm going to keep the negative. I know I'm going to replace something for the x, and I'm going to keep that minus 5. What am I replacing for x? All of f of x, which is minus x minus 5. So there is f of x, f into itself. Weird, weird concept. This is implicit. We want to give explicit, so we want to simplify. What do I do with all this negative and this brackets and all this stuff going on here? Yep. So negative times negative x. Negative times negative 5. And then I still have that minus 5 hanging around at the back there. And we simplify and we end up with... Math is awesome. Seriously, how do we take all of that? We end up with x. Questions so far? We could do composition of functions with rational functions. All the ones above were all polynomials, but it works the same way. Again, just make sure on the exam or a test or a quiz you're really looking at which dot they're giving you. Open dot is composition of functions. A black dot is multiplication. And those means two different things mathematically, so make sure you're looking. What does this mean? Well, if your brain likes seeing it the other way, the other notation would look like this. So f of g of x. It means g is going into f. G is the inside function. So all of g has to go into f. All of g has to go into f. So I'm going to keep that 1 on the top. I'm going to keep that plus 2 on the bottom. Instead of x, what am I going to put now? So instead of this little x here, what am I going to put here? That thing, yes, x over x minus 4. Now we have to simplify. Ooh, there's a lot going on here. Where do we simplify first? Yeah, well, I want to do the bottom first because I can't flip that fraction until this is one fraction. So if we just ignore the top and I gave you this, what would you do with it way back in grade 10? Unit 3. It's been a long time. How do we add fractions? Common denominator. So this 2 is over this imaginary 1 that we don't see, but we know is there. So what's the common denominator between x minus 4 and 1? Common denominator between x minus 4 and 1. just x minus 4. So each of these fractions is going to have to go over x minus 4. The top fraction or the first fraction isn't going to change because it's just times 1, so it's going to remain the same. What do I multiply by 1 to get x minus 4? So I need to multiply the top by x minus 4. And I'm going to actually multiply in the next step because I just want you to see what we're doing here. If your brain wants to multiply that right away, that's fine. So I still got this 1 on the top that I'll worry about in a second. All I'm going to do now is multiply the second denominator. So I'm going to keep the x over x minus 4. And here I'm just going to distribute. So 2 times x is 2x. And 2 times negative 4 is negative 8. We're still okay with what's happening? Okay, what do we do now that I have common denominator? So that's step 1 of adding fractions. What do I do now that I got it? Yeah, just add the tops. So keep the bottom, add the tops. So I still have that big 1 on the top. I'm going to have an x minus 4 on the bottom. And I'm just going to smush the top together, and I'll actually simplify it in a second. If your brain wants to combine that right away, it's fine. I'm just showing on this example step by step. So I can combine that x and that 2x. What's 1x plus 2x? So 3x minus 8 over x minus 4. Whew, okay, we're still not done. We now got to do the division. How do I divide fractions? Take the bottom one and flip it. What do we call the math word for that? Reciprocal. So I'm going to take the reciprocal of the bottom. So x minus 4 is going to go on the top. 3x minus 8 is going to go on the bottom. Can I cancel these x's? Well, why not? There's one on the top, one on the bottom. Come on, that would feel good to cross those out. Can I simplify the 4 and the 8? Why not? Because that's puppy killing, right? Can't cancel half a binomial. So this is our final explicit function. State its domain. To find the domain of a composition of functions, you must look at the NPV of the composition as well as the NPVs of the original function, or the inside function. So we know that the domain for a rational function starts with XER, but then we have to list all the non-permissible values. So let's go to the composition of function first. So our final answer here, what can x not be? What can x not be? So equate to 0, solve for x. 8/3. Okay, so add 8, divide by 3. But we also need to grab the inside function. The inside function is our g of x. So we have to state any NPVs of g of x. What's the NPVs of x over x minus 4? 4. That's how to do the domain of a composition of functions. So this first one came from our f of g of x. The second one came from our inside function of g of x. With a friend, but you won't. You'll do it by yourself, and that's fine. Try this one on your own first. Do g of f of x. We'll leave the domain. We'll do that together. But try to get a function for g of f of x. Again, for some people, the arrows might help. It might not for you, and that's fine. This time we're putting f into g of x. So I'm going to end up with negative root of x squared plus 2 times root of x. What do you remember about root of x squared? So if you square any root, what happens? It just becomes itself, so this is just going to be negative x. And then the other one, 2 times root of x, I'm just going to squish it together, 2 times root of x. Okay? That's the most simplified we can do. We can't simplify a regular x with the root of x. Domain. So we have to look at the composition, plus we have to look at the inside function. Sometimes the composition is a little bit scary because we've never graphed anything like this. The only thing you're worried about is any kind of asymptotes, any kind of restrictions, anything that's going to limit your domain. So negative x is just a linear function. There's nothing there that's going to limit the domain. There's no holes, there's no asymptotes. It's going to be just xer. What about the radical function? So what do you remember about the domain of radical functions? It can't be negative. That's the deal with roots, can't be negative. So what kind of values here does x have to be? It has to be positive. So the domain for all of this is going to be x is greater than 0. Can we have or equal to? So can I take the root of 0? Yeah, anything times 0 is itself, so this will be less than. And then I just have to make sure I go back and look at the inside function. Well, it's also root of x, so it's going to have the exact same restriction. That's done. Domain has to be x is greater than equal to 0. Okay, so sometimes when it's something funky like this, just think about the pieces. And you're looking for any kind of asymptotes, any kind of holes, any kind of restrictions on the domain. Show me a thumb. How are we doing so far? Doing okay? Doing kind of okay? Not doing okay? Put them up high so I can see them. Okay. Last thing we're going to do is just graph a composition of functions. So given f of x is absolute value of x, and g of x is x minus 3, we're going to find g of f of x, f of g of x, and we're going to graph them and see what happens and state some domains and ranges, because we can. Okay, f of g of x. What does that mean? Take g and put it into f. So g is going into f. So I'm still going to have that absolute value notation. It just means x is coming out, and what's going in its place? X minus 3. Can we simplify that in any way? Can I get rid of that absolute value? Nope, just stays the way it is. G of f of x means f of x is going into g of x. So instead of x, I'm going to put absolute value of x, high five back there, and then I still have that negative 3 hanging around at the back. And so the first point of this question was just to prove that they're not going to be the same thing necessarily. So if we switch the composition, we're going to get completely different functions. Well, let's go way back to Unit 1 in September with transformations. What do these two mean in terms of transformation? So what does it mean inside the absolute value if I subtract 3? So it's a horizontal translation. I heard somebody say it, 3 to the right. What's this one? That's a vertical translation. 3 units down. So mathematically, those are very different things. So either way, they're both going to start with the base graph of absolute value. Talk me through the base graph of absolute value. What does it look like? What are the points? Looks like a V. Okay, so give me some points on the base graph of absolute value of x. 1, 1. Love it. 3, 3. Ooh, getting creative. I like it. Now I got to think 1 1/2, 1 1/2. Oh, I did negative. Whatever, same thing. Give me some more points. I think you meant positive, Thor. Yeah, I'm with you there. And obviously the origin's going to be in there. So I'm just doing this one in pencil because he's just our base graph. He's not part of either of our compositions. See how it's all tying back to Unit 1, and Unit 2 tied into Unit 1, then Unit 2 tied into Unit 3, which tied into Unit 1, Unit 4. Then we're going to blow it apart with Unit 5 because it's got nothing to do with any of this. I'm going to color code it, so the same color I used up here I'm going to use down. So we're just picking this up, moving it 3 units to the right. So that is our f of g of x. G of f of x, I'm going back to the base graph, dropping it 3 units. So that's our g of f of x. Write down the domain and range of each. The first one, the f of g of x, what's the domain? XER, so standard absolute value graph. What about the range? It's frozen, you can't see that. What about the range? Except I think you wanted y there. What about our g of f of x domain? Yep, still the standard range, or standard domain. Range? And there she be.